Hi, my name is Percy and I'm an algorithm engineer at Deep Robotics. Today I'm going to introduce the ROS2 migration of our Lite3 robot based on our previous locomotion policy. So let me introduce the software structure a little bit. So previously, if you check the quadruped locomotion from beginner to pro series, we are using UDP communication between the locomotion policy and the hardware. So in the Lite3 RL deploy repo, there is a locomotion policy and it communicates with the joint and IMU through UDP. It gets the data and it sends the joint data command, the target joint pose, also through UDP to the low level. So right now for this repo, we have done ROS2 migration. So there will be another package that's going to get these UDP data and publish them in a ROS2 topic format. So and the previous locomotion policy will also be in a ROS2 node, and it's also going to publish through ROS2 topic, the joint data command, the target joints. It's also going to publish through the ROS2 topic. So if you look at the README here, so the repo we are using right now is this SDK deploy. So it does not only have Lite3 here, it also have the M20 here. And this is the first video of this series, and you guys can check that. So right here, we are using the Lite3 SDK deploy, which is the ROS2 version of our previous locomotion policy, the Lite3 RL deploy. So the data, the structure, the ROS2 structure here is pretty easy. We have this RL deploy, which is the locomotion policy. It communicates with, if it's in simulation, it's metrical simulation. If it is real world, it's Lite3. So it gets IMU data and joints data and publish joints command. And if we are using the gamepad, we have another node for the retray gamepad to control it through this gamepad. Okay, so now we can actually go into this repo. So before deploying anything to the real world, it's very important for safety to do a sim-to-sim test first. So we're also going to do that here. And so this is the ROS2 topic introduction. So for the IO deploy, it also like IMU, joints data command is just exactly what I described here. And for the sim-to-sim here, okay, so just git clone this. Okay, this is a little bit wrong. I need to. And we have git clone in here, and we're going into this directory and source the ROS2 environment and compile. So let me just remove everything to start again. And wait a second. And let it compile. So after compiling, we can do the sim-to-sim test. And as for the details of this folder structure, you can check the third video of the quadruped locomotion from beginner to pro series. That one has a very specific introduction to all the files in this folder. This one is just a ROS2 migration. The main structure is pretty similar. So we have this ROS metrical simulation coming up. One terminal for that, the other terminal for running the node. And it can just stand up, press Z to stand up, and press C to enter RL control mode. And you can just start moving like this. Okay, so this part is the sim-to-sim test. So we have do the sim-to-sim test and everything is working here. We are ready to do the sim-to-real test. So as I mentioned, we have another package that's going to get the UDP data and publish in a ROS2 topic format. So first, we need to compile, install that package, and then deploy our actual policy. So the actual, the package I just mentioned is the Lite3 transfer here. And we also have a Lite3 SDK service that's communicate between the robot and the app, and it can just auto start on boot. So the main package is this transfer thing here, but we need to compile these Lite3 SDK service too. So let's go into the robot. And since this thing is based on ROS2, and we need to install ROS2 first, and our previous Lite3 products doesn't have ROS2, so I'm going to show you guys how to install it on our Lite3 robot. And another thing I need to mention is that this repo and this process is only for the Lite3 Venture edition. No other edition is applicable. So okay, so let's first install ROS2 here. And to install ROS2, I suggest just follow the official website step. And for you guys in China here, you may need to switch the sources to for faster internet connection. So just copy and paste everything in the official website and install it. Okay, so now we have installed ROS2 here on the robot, and we can start using our start compiling and installing our packages. Okay, so to install our packages, we need to git clone this repo, this SDK deploy repo. And if you guys see in the README here, introduce that we have this SDK deploy, which is the Locomotion part, this SDK service, which is for the data transfer part. And yeah, this Lite3 transfer, this one manages this package. And the M20 is the M20 SDK deploy is also the Locomotion part. And we have another README for specifically for this Lite3 data transfer service. And this is actually the one we were seeing here before, this thing. So yeah, let's just go to the robot and follow the step-by-step. So preparation, use the requires network configuration and installing ROS2. Just do it step-by-step. Okay, so the first step is to go to this so as you can see that this one is already the same as this one, and we don't need to do any modification. Just exit and connect to the Wi-Fi. So for the first command here, list the possible Wi-Fi that Wi-Fi detected, and the next one connects it. So I think I have already connected here. And to test it, you can just ping like a external website. Okay, so I have already connected to external to a Wi-Fi that has internet access. You guys can do that, connect to your own Wi-Fi. So I'm not going to do that part here. Just going to continue the process. After connecting to the Wi-Fi, please attempt to ping external networks. So I have already succeeded here, and usually it succeeds. If it doesn't, just follow the steps to navigate it and go to this config YAML file and edit it in this way. It should be fine. And install ROS2. We have already installed ROS2. Just follow the official website step by step. This one applies to the widest range of cases. So I really suggest follow the official website. So all the preparation is done. We can git clone this repo. Yeah, so we can either git clone it or just transfer SCP the files from your own computer to the robot. So I'm just going to git clone it here. And if you can git clone it, you don't have to do the SCP, you don't have to transfer the files to the robot. So after git cloning the code here, we have this SDK deploy, and we can just remove everything here. And I have already removed the M20 SDK, so we don't need it here. That one is a different robot, and we can go back and follow this command. So we're now in the real robot, and we better use our retrade gamepad to control it. So there's something we need to change here. Is the Lite3 SDK deploy main.cpp. And this remote command type. Just use this K retrade gamepad and save. Okay. So we change to that, and we can just source it and compile. So after compiling, we can just run this SDK service. So this service manages the transfer package, and it communicates with the APP. So in our APP, so we can just click this SDK mode, and it talks to this SDK service, and SDK service manages the transfer package, and it starts getting the UDP data and publishes the ROS2 data. So just turn this thing on, and it's going to return to 0 position. And we can also change the frequency here for the ROS2 topic frequency. Now we have a node that's getting the UDP data and publishes the ROS2 topic. We have this Lite3 node up, and we're going to make the Locomotion node up too. So it can get the joint data and IMU data and publishes the joint data command, the target joints. So this one is a different README. Is this Lite3? This README is in the Lite3 SDK deploy. This README, okay. So what we just did here is that we have this thing up. Okay, and now we need to use this node. Let's go directly to the sim to real part, and this is what I just mentioned, this SDK mode. Just click this thing, turn it on, and use it. So we already have the code here. We don't have to SCP them, and we just need to compile them. But of course, first source the ROS2 environment and start compiling this ROS2, this package. So the compilation has finished. We can just ROS run, source and ROS run. Okay, and since we are using the gamepad, we can just click this to stand up and click this to enter IO control mode, and we can just control a little bit. Okay, it's kind of dangerous, so that should be enough. This is a two-node structure. ROS2 structure is very simple, and this part is the ROS2 migration of our previous Locomotion deployment code to the ROS2 version. So we have deployed the Locomotion policy, the ROS2 version, on the robot already, and we have two nodes running. The first node is the IO deploy, the other node is the transfer node. The IO deploy runs the Locomotion policy, while the transfer node gets the UDP data and publishes the ROS2 data. So these two nodes are running on the same computer, which is the robot, but this is not the point of this ROS2 migration. We already have a Lite3 RL deploy using UDP communication. All these nodes are just in one program. We don't have to do this ROS2 migration. So the best advantage of ROS2 migration is very easy to expand the hardware and expand the software structure. So we have very standard topics, and we can just subscribe and publish to that topic and establish communication. So to show this advantage, we're going to run the Locomotion policy, that node, on this AJAX O-ring. And we're going to mount this AJAX O-ring on the robot and establish communication through an Ethernet cable. And so one node runs here, the other node is still in the robot, and they can communicate still through this cable connection. And in that case, what if the Locomotion policy is already in an external compute, you guys can expand it even further, like mount sensors like LiDAR camera to enable external vision for input. And you can also embed some like VLA large language models into the algorithm too. So this is the point of this ROS2 migration, and we can just start installing now. So the first step is this, we need to mount these 3D printed structure parts on the AJAX O-ring. So we will also open source these models. Okay, and we need three types of screwdrivers here: 2 millimeters, 2.5, and 3. And for the AJAX O-ring, we need to use these two. Okay, so we have mounted this on the AJAX O-ring. And the next step is to mount this thing on the robot. So we have 3 holes here, 1, 2, 3, and we need to use these 3 screws here. And for these screws, it's kind of hard to install, so I recommend using a tweezer to okay. Okay, so we have installed them there, and so we have mounted this thing on the robot, and we need to plug in the cables. So the first cable is the power supply. We need to, so be careful, this the red is the positive and it goes down the bottom, and we need to use the port in the center, the 12 volts port, to power the AJAX O-ring. So this one goes here, and this the other one goes into the AJAX O-ring. And the next cable we need to plug in is the Ethernet cable. So this one, so my cable is kind of long, so I can go down here This one goes here, and the other ends. So this is too long. You need to and do it like this. Okay, so now we have connected the cables. So now we have mounted the AJAX ring on the robot, and we are ready to put the locomotion policy node on this computer and the transfer node on the original robot. Okay, so as you guys remember, we were on this Lite3 SDK service. So if we look at the README here, we build and run it, and we can make sure it has communication with the locomotion policy node. We can establish ROS2 communication. Now what we need to do is just change it to this computer, right? And another thing I want to add here is that so we can make this ROS SDK service node auto start on boot. So you just follow these commands, and you can check the status, can manage the commands. The managing commands here, you can use them to control it. And after doing the auto start with this node, you can use the app. The app has this SDK mode in the settings part. Okay, where is it? So in the app, you can just click this SDK mode, and it's going to send the data to send the UDP signal to the robot, and it's going to start sending out the ROS2 topic data, and we can establish the communication. Okay, so I have already, so okay, let me just shut down the robot and restart everything all over again. So first step, turn on the robot. Wait for some time to connect the Wi-Fi to the robot. Okay, so now I have connected the gamepad to the robot, and go to settings here and click this SDK mode thing. And it's going to go to 0 position. It means that it's sending out ROS2 topic data. Okay, and the next step is to go to the AJAX ring. So this part is a little bit complicated because we are not directly connecting to that. So we need to first SSH into the robot. And I have manually set the IP of the AJAX ring, the Ethernet connection, to be 192.168.1.45. So I can just SSH again, the name, okay, now I'm in the AJAX ring. So in the AJAX ring, you just git clone this repo again, or maybe you can just SCP to the robot and compile again. So just follow the sim to real part, SSH into it, git clone it, or you can SCP, source the ROS2 environment and compile. So yeah, let me just go in here. Remove everything and start again. So my AJAX ring is Ubuntu 22, and I have installed ROS2 Humble here. The step is the same as installing ROS2 on the Lite3 robot. Just follow the official commands step by step. Source it and compile. So as a reminder, right now we have already started the transfer node on the robot, right? So we click that STK mode, it's up, and now we need to start the locomotion policy node. So what we just did here, the STK service is managing the Lite3 transfer node, right? So it receives a UDP signal from the app and starts the Lite3 transfer node. So this is what it's been doing. Right now, we are trying to compile and start running the locomotion policy node. Okay, so compilation has finished. We can just source it and just ROS2 run. Okay, so we are still using that, and let me push a little bit far from me and click this button to go up, and click another button to enter IO control mode. The specific buttons are in the README, and also you can check our quadruped locomotion from beginner to pro series video, and we can let it move a little bit. Okay, so it's kind of dangerous on the table. Oh, okay. So yeah, so you guys can see that this is working, and we're just not going to test a little bit too much. So just let it go down, and this part is finished. So we can also check the ROS2 structure here. So let me just So if we just ROS2 topic list, we can see there's a gamepad data that's coming from the app, the gamepad, the IMU data, joints command is what the locomotion policy sends to the robot, and the joints data and IMU data are the data that robots send into the locomotion policy from the Lite3 transfer node, right? So if we ROS2 node list, we can see that there's 3 nodes. The structure is exactly the same as here. We have this retrain gamepad that's getting the data from the gamepad, the RL deploy, the locomotion policy, and the Lite3. Lite3 is the transfer node, it's getting data from the low level. So this will be the ROS2 migration of our locomotion deployment node code. And the point of this ROS2 migration is we can easily expand the hardware, add something else, and use that to control the robot. So this will be the end of this video, and let me summarize a little bit. So previously, maybe you guys would think that the robot is already a complex system, that you can do everything here. It has sensors, it has motors to be mobilized, and it also has a computer built inside. It's necessary, but that is actually wrong. Robots is only a component of a complex system, and the whole point of this ROS2 migration and this video is to show you guys how to actually make it a component, and it gets the low-level data, the IMU and joints, and publishes as a standard ROS2 topic. So it can be added to another complex system. And in our complex system, we mounted another external compute, and we are able to establish communication and use it to build a bigger system, not just this robot. So this kind of way of thinking is a crucial step towards advanced robotics. So advanced robotics is not something someone sell or someone that's already been built. You need to build it yourself. So we propose to give a component, and you can buy this component and buy something else and build a more complex system. Maybe you can have 2 robots, you can have 3 robots, or you can have a robot and a drone that can move together. So to build a more complex system as advanced robotics, it is necessary to think of a robot as only a component. And this is the most important takeaway for this video to how to modulize this robot and use it in a more complex system. So if you have further questions, you can join the Discord server, and also you can contact our technical support team, and good luck with your own development. Thank you.